the fifth chapter, periodic classification of the elements. The periodic classifications of the elements means what? Already we were aware of that. Periodic table contains, that is, S block, P block, D block and the F block. This means they contains metals, non-metals and the metalloids. See, based on the properties we can arrange here metals, non-metal and metalloids, where it is the present. In a provision store we can see soaps are arranged in one side, then food articles, that packed food items are arranged one, that oil arranged one places, then so many things like shampoo, like this shaving cream, they are arranged in the one place. So they have some arrangements. In medical shop, for medicine they arrange in alphabetical order, so they can easily find whether the which medicine is there. So easy that starting with that letter they can easily find out. So these arrangements also applicable in the periodic tables also, where metals are present, where the non-metals are present and where the metalloids are present. See, first we will discuss the making order out of chaos, that is early attempts at the classification of elements. That is making order out of chaos. So that is early attempt at the classification of the elements. Already we've seen that that is we have been learning how various things are that where living beings can be classified on the basis of their properties. The same things also we are following here. First, the earlier attempt to classify the elements resulted in the group in the known of the elements as metals, non-metals and the metalloids. Here, first the German chemist who is discovered in the triad system, that name is Dobernier triads. The German scientist name Johann Wolfgang Dobernier, simply Dobernier triads. Triads mean there is three system, that is three elements. He arranged in a three set of elements. That he arranged the elements with the similar properties in this group. That means, for example, that triad system, the Dobernier, so when the elements in a triad were written in the order of increasing atomic number, the increasing atomic number and the masses. The atomic number of the middle elements was roughly the average of the atomic masses of other two elements. For example, lithium, the symbol Li, sodium and the potassium. Here the masses, the respective mass for the lithium is 6.9, sodium is 23.0 and the potassium is 39.0. Here how does the compare of the atomic mass of this element? Some ambiguities are there, that is these elements are arranged downwards in the order and increasing atomic masses. For example, we will see some table that is group wise. This group A elements, the atomic mass N, nitrogen, phosphorus, arsenic. Then the atomic mass of element is 14, 31, 74.9. Then the group B element, calcium, strontium, barium, the atomic masses, calcium 40, 40.1, 87.6, barium 137.3. The group C element, chlorine, bromine, iodine, the atomic mass is 35.5 and 79.9 and last 126.9. So here you can, which one is find out the Dobernier triads. For example, this is the Dobernier triads. The Dobernier triads: lithium, sodium, potassium, and here the calcium, strontium, barium, and the chlorine, bromine, iodine. Here in these elements are arranged in the downward in the order of the increasing atomic masses. So here the Dobernier could identify only the triads from the elements known at the time of the lithium on the time. So this systems of the classification into the triads was not found to be useful. Okay, then we can move that simplified by the Newland's law of Octaves. Further, that is the detailed studies for the periodic classifications. Before that, Dobernier made the first observation on the platinum as a catalyst. The catalyst means enhance the speed of the reaction, PT, the symbol is PT. Platinum as a catalyst, and discovered similar triads of the elements which led to the development of the periodic table. So the development of the periodic table, next is the Newland Octaves. Newland law of Octaves. That's the attempts of the Dobernier encouraged other chemists also. Like he is the British chemist. The name is John Newland. He arranged the elements in the order of the increasing atomic masses. So he started with the element having the lowest atomic mass, like hydrogen. Hydrogen having the lowest atomic mass, and ended at the thorium, which was in the 56th element. So he found that every 8 elements has properties similar to the first. So he compared to the octaves found in the music notes, that is the musical notes. So therefore they are called law of octaves. The properties of lithium and the sodium were found to be the same. Sodium is the high 8th element after the lithium. So similarly, the beryllium and magnesium resemble each other. So the part of the original form of Newland Octaves is sa, re, ga, ma, pa, that is notes of music. Sa, re, ga, ma, pa, da, ni. So hydrogen, fluorine, chlorine, cobalt and nickel, bromine. Then in re side, lithium, sodium, potassium, copper, rubidium. Then beryllium, magnesium, calcium, zinc, strontium. Then like this, the similar way, boron, aluminum, chromium, terbium, cesium and lanthanum, like this. Then in this system, carbon, silicon, titanium, indium, zirconium. So like this. Then in this series, sodium, phosphorus, manganese, and this oxygen, sulfur, iron, selenium. So like this. See this, the musical notes. This is sa, re, ga, ma, pa, da, ni. So this is notes of music. Already we know. So in this notation we can use, that is do, re, that is do, re, mi, fa, so, la, ti. See the notes in the scale are separated by full and half step frequency intervals of the tones and the semitones. So the musician use these notes for composing of music of a song. So naturally there must be some repetitions of notes. So every 8 note is similar to the first one, and it's the first note of the next scale. So that he arranged like this. So it was found that the law octaves was applicable only up to calcium. After the calcium means, see, after the calcium, every 8 elements did not possess the property similar to that of the first one. So he assumed the 56th element, this is exist in nature, and no more elements would be discovered in the further. So but later on several new elements were discovered whose properties did not fit into the law of octaves. So in order to fit the elements into his table, so that Newland adjusted 2 elements in the same slot, but also put some unlike elements under the same notes. See here, the cobalt and nickel, look at this, are the same slot, and these are placed in the same column as like this. Similarly, cerium and the lanthanum. So here the chlorine, bromine, that is fluorine, chlorine, bromine, which have very different properties than these elements. So iron, which is resembled to cobalt and the nickel in the property, so has been replaced far away from these elements. So these are the called Newland octaves, law of octaves element. That is see some these he's worked only the lighter elements only. Then the next is the making order of chaos, the Mendeleev periodic table.